Now we will go move to the fourth experiment. Our fourth experiment is to write the program to develop ones and twos complement of a number. So here I have made two parts: finding the ones and twos complement of a number using negate instruction and without negate instruction. So whenever I'm using negate instruction, I will directly get the twos complement of a number. But whenever I'm not using negate instruction, I have to use not instruction, which is a logical instruction. Okay, so as usual, we will go to our TASM, type edit, go to file menu. I have already made two parts of the program. One is with negate instruction and another is without negate instruction. So I have given name experiment 4A and experiment 4B. I will start with 4A. Go to open. Here you can see names of the file names. Whenever we are doing any program and executed, that time four files are created. If you observe here carefully, add.asm, add.exe, add.map file, add.obj file. So one single program will create four files. One single program will create four files. Now we know the name of the program, name of the file. So in file name here directly I will type it expt4a.asm. Click on OK. So this is the program to find ones and twos complement of an 8-bit number without using negate instruction. So without using negate instruction, we have to find out ones and twos complement of a number. Now, as usual, of title assembler directive, I have written the title of the program. As we know that this program is very small, which requires less than 64 kilobytes memory locations. So I have taken small as an argument for dot model assembler directive. In data segment, we have data segment is initialized with dot data assembler directive. In data segment, I have written number one is the variable which is of size byte. So I of assembler directive defined byte, I have defined that variable number one and its value is 10h, which is a 8-bit number, and we have to find out ones and twos of a number. For that, I have taken two variable, one's ONCE, which is of size byte with the help of assembler directive defined byte. I don't know the value currently. I don't know value, so that I have pushed zero question mark. For twos complement of a number, I have variable twos TOWS, which are of type only, because whatever result we will get, that will be the byte of, that will be the ones and twos complement of this number 10h, which is a 1 byte size. Now, as usual, I have initialized the code segment with the help of these three instructions: dot code move ax comma add data, move ds comma ax. Now after that, I will get the result in I am using the AL register. So to at the start, initially the result should be 0. After that, it should be reflected. So I have taken AX as a 0. To why I have taken AX here? Because I want to show that AH is also not reflecting. Once AH is initialized with 00H, so it will show you the only contents of AL are changing. So that is the motto behind using this instruction AX comma 4 times 0H. Now what I have done, I have taken that data to the AL register with the help of instruction move AL comma number 1. In number 1, I have value 10H. So 10H will be copied into the variable AL. Okay. And I have written not AL. Not AL means it will complement or it will give you one's complement of a number. So whatever bitwise we have is here Bitwise, the number will be like this: 0, 0, 0, 0, 0, 1, and 0, 0, 0. This is the binary format of a 10H. Okay, which is represented in hexadecimal as 10. Now this will be inverted. So after execution of this instruction, we will get 1's complement of a number. So 1's complement of a number will be, it will be equal to 0 will be replaced with 1 and 1 will be replaced with 0. So it will be 1, 1, 1, 1, 1, 0, 0, and 4 times 1. So that will be equivalent to EFH. So 1110 stands for E and 4 times 1 stands for F. So our 1's complement will be EFH. We will get after in AL register, we will get the content EFH. Now that 1's complement we have got, we will place that into variable 1's, because here we are storing the 1's complement of a number. Now after getting 1's complement, if we add 1 to LSB position of 1's complement, then we will get 2's complement. So we will add 1, 0, 1 to the 1's complement of a number. Means if we add here, this is the 1's complement. If we add here, so this will be, here we have to add 0, 0, 0, 0, 0, 0, 0, 0, 1. So that has to be added. So to this also we will add 0, 1, H. Okay. So that will be, if we add 1, if we add 1 here in to this 1110, 4 times 1, 0, 4 times 1, and we have to add this 1 only at LSB position. So this 1 and this 1 will be added. It will give you 1 plus 1, 0 with carry 1. So again 1 plus 1, 0 with carry 1. 1 plus 1, 0 with carry 1. And 1 plus 1, 0 with carry 1. This one, see here carefully. Now we have generated the result. This one plus 1 will generate this 0 with carry 1 here. This 1 plus carry 1 will be generate 0 with carry 1 here. 1 plus will be 0 with carry 1 over here. So 1 plus carry 1 will be 0 with carry 1 here. And that 0 plus 0. 0 plus 0 will be 0 plus whatever carry we got from this lower nibble, it will be 1. Remaining will be 0, 0, 0, 0 will be added with 1, 1, 1. So it will be 1, 1, 1. So this number will be F0H. So 2's complement will be F0H. So you will get, whenever we are adding 1 to the f, so it will be 10. We know that after 9 in decimal number system, it comes to 10. So likewise in hexadecimal system, last digit is f. So if we add f, so it will be 10. If we 1 to the f, it will be 10. So 10 will be 0 with carry 1. So carry 1 will be added to the this e. E plus 1 will be f. So result will be f0. So whatever answer we have got, that is correct. And that answer we will copy into the variable 2's. So for that I have written instruction move 2's comma al. So and we have terminated the program with the help of these three instructions: move h comma 4ch int 21h end. Now we have done the program. We will save it. We will save it. Go to command window. Type tasm. File name is ext4a.asm. There is no error. Now object files are created. We have to link that object file with the help of command t-link. File name is ext4a.obj files we will link. We know that linker is the program which will link the object modules. Click enter. So no stack involved, and we will execute it with the help of command td. File name is ext4a dot exe. See here, dot exe I am using. First I have used asm dot asm, after that dot obj and dot exe. Now we have to use F8 for single step execution of the program. Observe carefully here. Program error is occurring. Program is not loaded. We will go back. We will go to edit for a dot asm. So everything we have done correct. We will save it. Then we will go to command window. Tazo file name ext4a dot asm. There is no error and there is no warning. After that we have to use t-link. File name ext4a dot obj td ext4a dot exe. The program is loaded. See here carefully. Look at AL register. First it will be initialized with 00h. Now see, after execution of move x comma 00h instruction, the data of x register will be 4 times 0h. Now we have moved our data number one, that is 10h into the AL register, and now we will find 1's complement. If you observe carefully, we got 1's complement of a number EFH, and then we add 1 to it to get 2's complement. Now in AL we will get 2's complement F0H. So whatever we have done, that is correct. If you observe carefully here, auxiliary flag is set to 1. Why auxiliary flag is set to 1? When we add 1 to the EFH, there is the carry from lower 4 bits to upper 4 bits. lower nibble to higher nibble. That's why the auxiliary carry is set here. Okay, so that's why it is 1. And also parity, about parity, parity flag. Here the parity in F0H, we have 4 ones and 4 zeros. So even number of ones will set the parity flag. So P will be equal to 1. Program is completed, terminated. Okay, so this is how we can find the ones and twos complement of a number without using negate instruction. Now we will use negate instruction and we will find ones and twos complement of a number. That will be the second part of the fourth experiment. So I have 4B. I will open it. So this is the program to find out ones and twos complement of a 8-bit number using negate instruction. Now in negate instruction, what is going to happen there? Once actually directly after execution of negate instruction, we will get directly two's complement of a number, and we have to get the ones complement, we have to subtract 1 from that two's complement, or we have to increment it by 1. So as usual, I have defined dot model small dot data, and number 1 I have taken as per previous. Same thing I have written here. Ones defined by question mark, twos, because I have ones and twos complement currently. I have initialized the code segment with these 3 instructions. Move dot code is the assembler directive, indicates the start of code segment. Move x comma add data, move ds comma x. So these are the initialization of code segment. In code segment, I have written initially I don't know the ones and twos complement, and I am using the AL register. So I have used AX register, and it is initialized the value 4 times 0H. Now what I have taken, I have number 1, that is 10 value, 10H in the variable AL, and I have used negate instruction. After negate instruction, directly I will get the twos complement of a number that will be stored in AL register here. So here I will get F0H, which is the twos complement of a number. So I will move that twos complement of a number in variable twos with the help of instruction move twos comma AL. So content of AL will be the F0H. F0H will be copied into the variable twos. Okay. Now I got twos complement. I want to find out ones complement. So we know that whenever we are adding 1 to the ones complement of a number, then we will get twos complement of a number. So here we will do a reverse process. We will subtract 1 to get ones complement of a number. So that I have used the instruction move AL comma sub AL comma 0 1H. So here content F0 will be subtracted to 1. So content of AL after execution of this instruction will be EFH, which is a ones complement of a number. And I will store that ones complement in the variable ones. Sorry. So here we will store ones complement of number to the variable ones. And as usual, we have written termination of program move h comma 4ch int 21h end. These are the 4 instructions, 3 instruction which is used for termination of the program. We will save this program. Click on exit. Type tasm. File name is expt4b.asa. So there is no error, there is no warning. T-link, file name is expt 4b.obj. td, file name expt 4b.exe. Click on OK. Expand this. Now we will run this program with the help of step by step. We will see the execution. So for stepping, to execute the program step by step or using executing single instruction at a time, which is called as stepping. So stepping will be done with the help of F8. So if you observe here they are given instruction F8 for step by step execution. So here I will use F8. So here if you observe carefully, after the instruction move ax comma 00h, the content of ax will be 0000h. Next, number 1 will be added to the AL register, and negate instruction now it will be executed. So directly we will get 2's complement of a number. If you observe carefully, we will got 2's complement of a number. After that, we will subtract it 1 to get 1's complement. See here, we have got 1's complement of a number, and the program is stopped, terminated. So this is how we can use negate instruction to find 2's complement of a number, and from that we will find 1's complement of a number. Go to file menu, quit, exit. Thank you.